Good morning. This is the lesson for Math 1 for March 16th. So today we're going to be talking more about qualities of these different triangles. We're going to focus on the sum of the interior angles of triangles to start. So as you can see here, it says you can classify triangles by their angle measures. An equiangular triangle, for example, is a triangle with three congruent angles. So here are the examples of triangle classification. We have an acute triangle where all angles are acute, meaning they're less than 90. We have a right triangle where one of the angles is a right angle, meaning it measures 90 degrees. And then there's your obtuse triangle, where we have one angle which measures more than 90. So here's some examples. Classify each triangle by its angle measures. Okay, so since this one has a right angle, then we're going to call this a right triangle. Looking at the angle measures for this triangle, since we see one of the angles is bigger than 90 degrees, then we're going to call this an obtuse triangle. And with the third triangle, right, carefully looking at all the angles, because each of them measure less than 90, all three of them measure less than 90, then we're going to call this an acute triangle. You can also classify triangles by their sides. So when we have, and we all know an equilateral triangle means all three sides are the same measurement. An isosceles triangle, where we have two sides congruent, two sides having the same measurement. And then there's a scalene triangle, where none of the sides are the same length. Again, we can classify these triangles based off of their side measurements. Here we see all three sides are the same, so we're going to call that an equilateral triangle. Adjust this real quick. There we go. We have this next triangle, since all sides are different, they are going to be called a scalene triangle. Looking at the third triangle, two sides exact same length, so it's isosceles. And the last one here, again, two sides the same length, that is also an isosceles triangle. Okay. Alright, so now I'm going to go back to talking about the angles of a triangle. So it says here, the sum of the angle measures of a triangle is 180 degrees. So now again, we notice that we're angling the triangles with these capital letters, so the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C, all add up to 180 degrees. Okay, so that's an important theorem to remember. So when we're looking at problems like this one, since one angle measures 25 and the other measures 35, we want to find the measure of that third angle. Okay, so we're going to take out our calculator here. So if all three angles measure 180, to find that third angle, we're going to take 180 degrees. Start, subtract 25, subtract 35, and what we're left with is 120. So that third angle has to measure 120. And we can check this by, well, let's write in the 120 first, so that angle right there is 120 degrees. We can check our answer by taking those numbers again, 120 plus 25 plus 35, and okay, yeah, it does add up to 180 degrees. Looking at this next example, just find the missing angle measures. Okay, so I'm going to do one at a time here. So let's find angle 1 first. Okay, we want to choose this one first because in this triangle, right, we have 2 of the 3 angles, right? You don't want to start with this triangle where we only have 1 angle measurement that's given. Okay, so we're going to start with this one. So again, we have 2 of the angles. So just like what we did with the first example, we are going to take 180, subtract 90, subtract 58, to get 32 degrees. Okay, so that's the measurement of angle 1 in there. Angle 1 is 32 degrees. Alright, so now to find angle 2, there's this theorem that we need to talk about here that's going to help us find angle 2 real quick. See how these angles 1 and 2, they kind of form an X? Alright, so I can kind of do this. Alright, if you can make an X, you have these angles that are across from each other. Those are called vertical angles. Okay, vertical angles. And the thing you know about vertical angles is that they have the same measurement. So, angle 1 is 32 degrees, then the angle across from it, which is a vertical angle, also measures 32. Okay, so if you can make that X, right, those are called vertical angles. Alright, I'll write that here. So, vertical angles. Alright, so vertical angles have the same measurement. So, angle 2 also is 32 degrees. Alright, so now we need to finish up this example by finding the measurement of angle 3. So now that we have 2 of the 3 angles here for this triangle, again, using our calculator, we're going to take, let's go this way, 180 minus 108 minus 32 equals 40. Okay, so there is the measure of angle 3, 40 degrees. Alright, so let's do a little practice. Find the missing angle. So here again, triangle, 2 of the angles we were given. So we do 180 minus 65 minus 57 is 58. Here we have a 90-degree angle and a 40-degree angle. So to find the missing angle, we'll take 180 minus 90 minus 40 is 50 degrees. So that gets us this angle. Right. And with this last example, okay, we'll start with the bottom triangle. Right? Again, because we have 2 of the 3 angles of this triangle. Let's do 180 minus 20 minus 40 is 120. So we write that right in here. Now we're trying to find this angle right here that's a question mark, but again, if we're going to find that, we need to know what this angle is in this triangle. Again, because these are vertical angles, right? You can see the X, right? You can make an X. The angles that are across from each other are the exact same measurement. So that one is also 120 right there. So again, to find the measure of this missing angle, we're going to take 180 minus 120 minus 39, and that equals 21. So we got that angle to measure 21 degrees. Alright, so now we're going to do some problems that mix in what we just talked about, these concepts with some algebra, so solving equations type stuff. Alright, so now here we don't really have a lot of equations, so we're looking at, again, trying to find x, y, and z. So again, you always want to try to start with a triangle. And we could see there's a couple of triangles for sure, and actually there's a third one, right? This big giant triangle right here. Alright, so you want to start with a triangle that has 2 of the 3 angles already figured out. Okay, so we're going to start with this one that's off to the left. So again, since we have 2 of the 3, we'll start off with 180 minus the 64 minus the 30, and that gives us 86. So that's this triangle right in here. Okay. So now we need to figure out y and z. Let's put 86 right here. So again, if we're looking at the big triangle, the bigger triangle here, right? This angle is 50, right? So if I kind of draw the picture of the bigger triangle. So this is the bigger triangle. So 30 plus 20 is 50. So this big giant angle here is 50. This one is 64. Here is angle Z. So again, I'm looking at this big triangle. 50 on top, 64 in that corner, and then here's Z in the bottom corner. Alright, so we're going to figure out actually Z first by taking 180 minus 64 minus 50. And it gives us 66. 66 degrees for that one. Right. So now we're going to switch gears back to finding y. So again, we're going to focus now all our attention on this triangle right here, where we now have 2 to 3 angles of that triangle. I'm going to do 180 minus 66 minus 20 equals 94. 94 degrees. Moving on to this practice problem. So here that is for that angle, and that's for that angle. So we have angle T is 2x, angle X is 3x plus 6, and angle Z is given this expression of x plus 6. So we want to find angle Z and angle T. So to find angle Z and T, we need to solve for x, right? So the only one that can really solve for x here is this one, because we know that angle x is a 90-degree angle. Right? That little box there tells you it's 90 degrees. So we're going to start off by setting the expression that represents that angle equal to 90. Alright, so you guys know how to do this. So we're going to subtract 6 from both sides. So I have 3x is equal to 84. Divide both sides by 3. I get x is equal to 28. Right. So now that we solve for little x, right, that's that variable x. Now we can figure out angle T and angle Z. Alright, so we're going to plug 28 in for x. So we're going to do 28 plus 6. That gives us 34. So there's angle Z. And then we'll plug in 28 for x here. So 2 times 28 equals 56. So there's measurement of angle T. Okay. Alright, so it's looking like we are down to the last minute here for this particular video. Please go to the second link, which will give you the second half of the lesson.